not carboxylic acid, how would you identify to come up with exact name? First, we are going to determine melting point as one physical property, then the solubility. Then we go with the classification test to determine the functional group. And when we have the functional group, then we have to do like derivatization, or we do titration in order to find out what is. We use titration only for carboxylic acid. And if it's other groups, then we prepare proper derivatized compound. In this experiment, we said that your unknown is going to be either aldehyde, ketone, alcohol, or it would be carboxylic acid. So we have limited number of functional groups. So we have specific derivatization. So to do the melting point, I'm using one sample for quick melt. So with the quick melt, we're going to get the sample melting at like a high setting of the power regulator. So this is my quick melt, which I'm not using for the data collection, but I want to know approximate melting point, and then I use the chart for setting. For carboxylic acid has high melting point, and I use that analogy using of a quick melting sample. It's always the best way to go. This one is set at 4 or 5, and if it melts less than 100, I have to adjust. If it melts over 100, over 150, I have to adjust. The temperature is 46 and is already melted. So whatever it is, melting point of this sample is less than 46. And because it's less than 46, setting the temperature or power regulator between 4 to 5 is very fast heating. I need to lower and adjust this. And so if it's 450, it's going to be between, the setting needs to be between 1 and 2. So it would be around 2, slightly less than 2, I choose. And I'm gonna have to wait for this to cool down to like 30 degree maybe, or to lower temperature, so I can get the, start my new sample. Melt, if the thermometer already, if the meltum is showing higher temperature, as soon as I put the sample, it would melt. So it defeats the purpose. It has to be, the temperature has to be lower than the melting point, 10 degree lower than the melting point of my sample. The temperature is around 30 and the setting at 2. I'm going to prepare my new sample with the second sample to test the melting point. So we place the capillary tube in and machine is on, setting at less than 2, like 1.8, and wait for the melting. It's melting quickly, or rather quickly, so it's just going to monitor the melting, starting to melt at around 46. I'm going to take a picture. 47, and it's already melted, so 46 to 47. See, I just want to remind that for this experiment, the students are using one of the unknowns only, and the professor is going to assign which one. We're doing the solubility test. For the solubility test, I use tip of the spatula, as we have been using tip of the spatula to approximate 0.1 gram of the sample. I'm using that with 3 full dropper, again, to approximate 3 milliliters of the sample. I'm using 3 full dropper. And full dropper, you squeeze the rubber ball completely, release it in the liquid, and remove it when it's full, and transfer. Check for solubility in water. the powder kind of stays on at the surface and is not mixing, is not dissolving, you shake it about 10 seconds and check. This sample is not soluble, so we just record not soluble. Move on to the next solvent. The next solvent would be HCl. So if it does dissolve in water, we should not do any other solvent. But if it does not dissolve in water, next we are going to check with the HCl. So tip of a spatula, about 0.1 gram of the sample, and 3 full dropper of the HCl. And mix it well for 10 seconds and check for solubility. Is not clearing. And is not soluble. So not soluble or unknown B is not soluble in HCl either. Since it's not soluble in water and HCl, we would use 10% sodium hydroxide and test the solubility in sodium hydroxide. Again, same, be consistent, same amount of the solid. And 3 full droppers of the solvent. It did not dissolve in sodium hydroxide. If it doesn't dissolve in sodium hydroxide, that means the compound is not acidic. So if it doesn't dissolve in sodium hydroxide, there is no need to test with sodium bicarbonate. We only test with sodium bicarbonate if it dissolves in sodium hydroxide. So the last solvent that we are going to check would be sulfuric acid, and that is concentrated sulfuric acid. Going to see if the sample is going to dissolve or to react with the sulfuric acid. Going to mix it for 10 seconds and check the appearance. The solution turned clear because it's solid in the liquid. So if it disappears, that means it's soluble. So the conclusion here is that the compound is soluble. It's a slight color change, but since the solid disappeared, we already can say that the sample is soluble in sulfuric acid. What does it mean if the sample is soluble in sulfuric acid and not soluble in sodium hydroxide or water? Means that the compound is polar, but it has high molecular weight. Out of the choices that we had, carboxylic acid, alcohol, ketone, and aldehyde, this compound could be alcohol, could be ketone, or could be aldehyde. Definitely is not carboxylic acid. Now, to prove or to distinguish is like, because with this, we just narrow down the number of possible functional groups. So next step would be our classification test. If the unknown forms colored or strong color with ceric ammonium nitrate, then it's alcohol. If it forms precipitate with 2,4-dinitrophenyletrazine, then it's going to be either aldehyde or ketone, and that's what we are trying to do next. Okay.